Hey, what's going on, everybody? It's Joel Irway with dailyfeexamprep.com, and today we're going to be covering a statistics lesson number 1 in statistics, and it is going to be regarding standard deviation. So just a quick shout out, this one is recorded for Sheldon, who submitted a content request form asking me to cover a couple topics in statistics. So thanks, Sheldon, for requesting that, and hopefully this serves you and anybody else watching. Hopefully it's extremely beneficial to them. So that's my intent for this. So let's get started. So the goal for today's lesson is for you to leave with having a complete understanding of what standard deviation is, how standard deviation applies to understanding a data set, and you're going to learn how to interpret standard deviation. So the general overview for the lesson is we are first going to define standard deviation. Why is standard deviation important? We'll discuss that, and we'll work through an actual example of standard deviation. And finally, we'll end on a further examination note, which we will discuss the two main types of standard deviation and how they are different and when we apply each of them. So first of all, standard deviation. The definition of standard deviation is the average distance from the mean value of a particular given set of data points. Okay, so the average distance from the mean value of a particular set of data points. Okay, and the formula is given as such. S, which is the standard deviation, is equal to the square root of the sum of each data point minus the mean value of that set of data points squared divided by n minus 1, okay, where S is the standard deviation. Sigma, which is the sum of the x minus x bar squared. X is equal to each individual score, and x bar is the mean or the average of the scores. Okay, so x bar didn't show up in the lesson, but that's what that is. And n is our sample size. Okay, so if you look to page 33 of the NCEES Supplied Reference Handbook, version 9.2, they give a couple different formulas for standard deviation, and I highly recommend that you practice rewriting them because they are a little confusing in the handbook. Okay, I think they're given as like either 1 or 2 lined items, and when I looked at it, it was quite confusing. So I would practice rewriting it to a form that you're comfortable with working with. So this is the form that I'm using, is the one that I'm listing up here. So why is standard deviation important in statistics? Well, for one, it tells us how much each score varies from the mean value. Okay, the larger the standard deviation, the more spread out that the values are, and the more quote-unquote different that they are from one another. Okay, it really expands on, or it tells more of the story for a particular data set. And let's work through an example so I can really explain that better. So let's say that you're considering a new job and you're looking at the starting salaries that particular employer offers. Okay, well, the average starting salary you found is $100,000 per year for every new employee. Okay, and you know that there are 5 employees. And you might think that, hey, that number is great. And you might be thinking, sweet, $100,000 per year, that's what I'd be thinking. You don't really have a true understanding of what it really means looking at just the average starting salary per year, the mean value, looking at it at face value, unless you have the standard deviation, which will reveal a whole lot more about that particular data set. So let's take a look at 2 different sample sets and to further explain this point. Okay, sample 1, we've got 5 employees, like I mentioned, and their starting salaries are as follows: $90,000 per year, $95,000 per year, $100,000, $105,000, and $110,000 per year. Sample set number 2 of the 5 employees is employee number 1 is making $60,000 per year. Employee number 2, $90,000 per year. Then employee number 3 is making $135,000 per year. Employee number 4 is making $175,000 per year, and employee number 5, well, they're only making $40,000 per year. Okay, you see the difference between the 2 sample data sets? You probably can, but let's get more technical and solve for their standard deviations. So the standard deviation calculation for sample set 1 is using the formula that we talked about in the beginning of the presentation, which I've listed right here on the right-hand side, let's go ahead and calculate it out. So you list first of all, what I did was I listed all 5 data points. Okay, so I listed the 5 employees' starting salaries on the left-hand side. That's variable X. Okay, then what I did was I listed X bar, which is the mean value of all 5 data points, which we know is $100,000. Okay, next, step 2, I subtracted X from X bar, and I took that value for each of the 5 data points. And then finally, what I did was I squared it. Okay, so for example, for employee number 1, $90,000 minus $100,000, that X minus X bar is equal to minus $10,000. Well, when I square that, I come up with $100 million. Okay, and so what I did was I did that for all 5 data points, and then at the bottom, I summed up that value. So what I'm really doing is I'm just working through this formula step by step. Okay, so the sum of all of those X minus X bar squared values is $250 million. Then I divided it by n minus 1, which n is our sample size, which is 5, minus 1 is equal to 4. So $250 million divided by 4 is equal to $62.5 million. And finally, I just took the square root of that to get the standard deviation, and I ended up with a standard deviation value of $7,906. Okay, so what that's telling us is that any given salary is an average of plus or minus $7,906 away from the average salary or the mean salary. And so here we have a close range between each employee. Now, the data points are less different from one another. That's what that means. So let's take a look at sample number 2. We've got the same formula and just new data points. So I've listed them all out under X and subtracted X from X bar for every data point. And then I squared the value. So for employee number 1, I have $60,000 minus $100,000 equals minus $40,000. Then I square that value and I get 1.6 billion. I do that for all 5 employees, and I sum up that total at the bottom, and I get $12.15 billion. Divide that by n minus 1, which is 4, and I get $3,037,500,000. When I take the square root of that, I come up with $55,114 as my standard deviation. Okay, so that's a substantially larger number than the standard deviation we found in sample size 1. So what that means is any given salary is an average of plus or minus $55,114 away from the average salary value of $100,000. Okay, that's a substantially higher spread. So if you were looking at that, now if you had that data when you're looking at the starting salary, you might be thinking, okay, well the average salary is $100,000, but I could be way on the bottom of that scale, or hey, I might be on the top. You know, you really just don't know. So each data point is very different from one another. So under further examination, in general, the standard deviation tells us, like I mentioned, how different each data point is with respect to the average value of the data set. Okay, and there are actually 2 types of standard deviation. One is the population, which is just divided by n, and 2 is the sample standard deviation, which is what we used, where we're dividing by n minus 1. Well, why does that matter? What's the difference? Well, the sample standard deviation is used to be more conservative and to err on the side of caution. Okay, so if you divide by n minus 1, we're actually forcing the standard deviation to be a slightly higher value than if we were to divide just by n, right? Because if you divide by a smaller value, like n minus 1, the end result is always going to be a higher value when you divide by a smaller number. So scientists use this just to be conservative and account for any sort of error. That's what the sample standard deviation is really used for. Okay, so that is lesson number 1 in statistics, and just a quick shout out. Thanks again, Sheldon. Please, if you're watching this video, please help me build and grow this engineering community. My goal is for this community to be the go-to source for FE exam preparation, and I need your help to grow that to the size that I'm shooting for. So please help me do that. Check out my other lessons and sample problem videos on either my website, dailyfeexamprep.com, or my YouTube channel, youtube.com/dailyfeexamprep. So please follow and like those websites and comment on the videos and let me know what you think. Also, please like and share the videos with your other engineering friends so we can help grow this community, and check out all of my other videos on those sites. So let me know, what are you struggling with that I can teach? Go to dailyfeexamprep.com/content request and let me know. Just like Sheldon did on this video, please email me. Let me know what subjects you're struggling with, so I can create lessons and example problems to help teach you. So I'm trying to be the distilling resource. Let me be your research arm for topics that you're struggling with. So yeah, let me know. Head over there or shoot me an email at joel@dailyfeexamprep.com. Okay, I've already gone too long in this video, so thank you so much for watching, and stay tuned for the next one.